about the last physical item you bought online? You clicked a button, paid a shockingly low delivery fee, and a few days later, a cardboard box arrived. We rarely consider the physical geography that item had to cross, but statistically, it traveled across an ocean inside one of 20,000 steel boxes stacked onto a cargo ship the size of a skyscraper. When we look at these massive vessels, we naturally assume they run on a colossal amount of standard diesel fuel. But moving 100,000 tons of steel across the Pacific on highly refined diesel would cause the cost of international freight to multiply overnight. Cheap electronics, fast fashion, and imported groceries would become luxury items, ending the affordability of the modern economy. To keep moving a television from Shenzhen to Los Angeles down to just a few dollars, global logistics engineered a way to use something completely different. The supply chain relies on a hidden physical energy system, contradicting our standard assumptions about transportation. To understand why ships use this substance, you have to look miles inland, inside the towering steel architecture of an oil refinery. Crude oil is heated to 400 degrees Celsius to separate its hydrocarbons. As vapors rise and cool, they separate into propane, gasoline, aviation fuel, and diesel. Below these premium fuels, the molecules get heavier, leaving a dense residue at the absolute bottom. This is heavy fuel oil, or bunker C. It is a dense, toxic residue packed with concentrated sulfur, heavy metals, and carbon sludge. At room temperature, it becomes so thick and viscous you can practically walk on it. For a refinery, this residue is an unwanted byproduct they price aggressively to get rid of. For shipping companies, it provides the cheapest thermal energy on Earth. The result is an economic marriage that subsidizes the modern world. Choosing to burn the thickest fuel on Earth creates severe mechanical problems. You cannot simply pump heavy fuel oil into a standard engine. If you tried, the sludge would clog the pipes, shatter the fuel pumps, and tear the engine cylinders to pieces. To use this waste product, ships are laced with a hidden utility network of steam pipes. Water is boiled using excess heat from the engine, and this high-pressure steam is piped directly through the massive fuel tanks deep in the belly of the vessel. These heating coils run 24 hours a day, providing constant warming to millions of gallons of sludge to keep it in a liquid, pumpable state. If the steam system fails, the fuel solidifies, the engine starves, and a ship carrying hundreds of millions of dollars in cargo becomes completely paralyzed in the middle of the ocean. The engineering required to manage this fuel transforms a cargo ship into a floating, highly complex thermal processing plant. Even when heated into a liquid, the fuel is highly contaminated. Because it is the literal bottom of the barrel, it is packed with microscopic shards of aluminum and silicon called catalytic fines. If these microscopic rocks reach the engine, they act like liquid sandpaper, scoring the massive steel cylinders. Deep inside the engine room, the oil is pumped into massive centrifuges, known as purifiers. Looking at this top-down view, the machine spins at thousands of revolutions per minute. The extreme centrifugal force violently throws the heavy contaminants to the outside edges, allowing the lighter, cleaned oil to be drawn up through the center. There is one final physical hurdle. For an engine to burn fuel efficiently, the liquid must be atomized, sprayed as a fine, microscopic mist so it instantly ignites. But heavy fuel oil is so thick that it naturally resists atomization. If you try to spray it, it just globs out. Before reaching the engine, the cleaned fuel is pushed through a final series of extreme heaters. The temperature is cranked up to over 130 degrees Celsius. At this exact thermal threshold, the viscosity drops low enough that high-pressure pumps can force the liquid through the microscopic holes of a fuel injector. Only then is the fuel blasted into a marine two-stroke engine. These are the largest internal combustion machines ever built. A single cylinder on an engine of this scale is large enough for a person to stand inside. When the superheated heavy fuel oil is atomized, a piston compresses it. The extreme pressure detonates the sludge, driving the massive steel crank forward. This hidden sequence of fluid dynamics and thermodynamics happens thousands of times a minute, for weeks on end. It is the actual mechanical force pushing global trade. For decades, this system operated completely out of sight. But because heavy fuel oil contains concentrated sulfur, burning it releases sulfur oxides into the atmosphere. This exhaust creates acid rain, causes respiratory problems in coastal cities, and heavily pollutes the marine environment. Eventually, the scale of this problem forced a reckoning. In 2020, the International Maritime Organization instituted a massive regulatory shift, capping the amount of sulfur ships were legally allowed to emit. This regulation required the shipping industry to find a way to continue using the most affordable fuel on Earth while meeting the new, strict environmental limits. The solution was to retrofit vessels with massive chemical washing machines directly inside their exhaust stacks. These systems are known as scrubbers. When the heavy oil detonates in the engine, the toxic exhaust gas is forced up through a towering steel silo. Millions of gallons of alkaline seawater are sprayed directly downward through the rising smoke. The chemistry of the seawater reacts with the sulfur gas, scrubbing it out before it reaches the open atmosphere. Solving the pollution problem did not eliminate the toxic fuel, but simply required building yet another massive layer of hidden chemical infrastructure to contain it. So the next time you receive a package from across the world and you marvel at how cheap the shipping was, remember that the price tag is an economic illusion. This cheap delivery is fueled by a backstage network of high-pressure steam, roaring centrifuges, and cathedral-sized engines, all engineered to extract mechanical force from the industrial garbage of the oil industry. The frictionless modern world is entirely subsidized by an extreme physical reality operating far out over the horizon, designed to burn the unburnable to keep the planet in motion.